So we have been dealing for up until now with situations where we were applying just uh, one function at a time, right? One aggregation function at a time. Okay. Now we're going to start to apply multiple aggregation function. Okay. So you can say uh, how many entries are there. So we are again asking questions from the data set. Okay, from this data set, how many entries are there in the housing column for each job category in total? Okay, how many own a home for each job category, and the proportion of them that own a home by job category. Okay, a proportion means mean, like the average, right? Because you have ones and zeros, so when you average them out, you're going to have uh, the proportion of the home, where proportion of the folks who own homes. Okay, so you can do it by housing, by job, and for the column housing, you're going to apply this three aggregation function, and you're going to get that. Okay, uh, and I think we have been through that non-null versus null. So how many non-null entries are there in the housing column for each job category? How many entries are there? Okay, that means you'll use count, which we are going to use. Okay, how many own a home for each job category and the proportion of them. Okay, so we're just doing some basic aggregation by housing or by job for the housing column. Okay, and remember we purposely inserted a not a null value, a null value in the loan column. Okay, and so we're going to just compare the size versus count one more time, and you will see that that is one of them is going to have one less when you do count. Okay, because it has a null value. Okay, right there, unemployed. Okay, so I think this is where we inserted a null value, and you can see that there is a difference between size and count. Okay, size takes into account everything including null, and count does not. Okay, we can also rename columns. Okay, so for example, here it's called count, sum, and mean. Okay, and let's say you want to present it to someone, and let's say you want to export it out to some ACSV file, for example. Okay, you can also rename columns. Okay, and we're going to rename the columns here, and unfortunately this syntax is pretty custom, so you want to sort of keep a record of it when you are say working on a project or working on anything on your end. Okay, and yeah, so you just want to keep track of the syntax, and what I typically do is I keep this Jupyter notebooks say on GitHub, right? And I will use that as a reference. I don't care if anyone else wants to use it in the world, right? Because anyone else can technically view it if it's a public repository. And we're going to have a few videos on how to use and implement GitHub, right? But yeah, so I keep that handy just in case whenever I'm working on something and I want to go back and refer to it. I will just quickly sort of browse through my notes and use that. Okay, and you can also, as we discussed, you don't have to use the aggregation function. If you wanted to redesign your own aggregation function, you can do that as well. So here we are doing mean, and then you are applying some lambda function. Okay, so for each job category, find the average age and the spread of age, max minus min, right? So we are saying that this is one column, okay, of this aggregated data frame, and this is another column. This one column should use mean, the other one column should use a custom function, okay, which we defined. Okay, so it does give you that. We can also aggregate on multiple columns. Okay, so here we are doing aggregation on only one column, for example age, right? And here we were doing it on housing. We could do it by job. Okay, so say for each category compute the proportion of customers with a housing loan, the maximum age. So housing loan is one column, maximum age of a customer per job category, that's another column, because that's a different column. And just for the heck of it, calculate the gap between the max age and the mean age of the customer. Okay, so that is another thing you would want to sort of take note of, and I think it's a bug. Okay, it's a bug in there. I'm not sure it's going to be cleaned out, but you want to keep a record of it. So you see it gives an error. Okay, it gives an error. It's a strange error saying that its age is not in the index. Okay, And the reason it is giving an error is because you are using this age column 2 times, okay, and somehow it throws an error, okay, when you're doing aggregation by custom aggregation for and multiple aggregation in the same thing, okay. So what you would typically want to do is say you want to call that you want to create a new column in the data frame, okay, called age temp. And if you look at the data frame, now you will have a new column age temp. It's the same column, okay, same age column, but now you can do this custom aggregation, okay, by this age temp, okay, and you see that now it doesn't throw an error. So it's a little strange, okay. It's obvious that it's an error, right, because it's obvious that it's a bug, right, age no. So problem here, same code except a new name for that age column, and no problem, okay. And of course, once we are done, we're going to drop that. We don't want to change the data frame we are working on. We can also create a hierarchical index, okay. For example, if you wanted to group by 2 different columns, okay, say I want to group by job and education level, okay, you can do that. So these are all the jobs, and within each category of jobs there are three types of people who have 3 different levels of education, okay, and we are doing that. So in one snapshot you have a mean average of folks who own house, average of mean of age, folks who own a home, and folks who have an outstanding loan, okay. And I'm not sure whether it's very easy to read, but yeah, I think that's it. So you can also flatten it, okay. If you wanted to sort of not have this kind of a structure, you can also flatten it like this, okay. And here you have admin 3 times, blue collar 3 times, and so and so. Admin 3 times, blue collar 3 times, and so and so. It's your preference, okay. And we can also do, what is this doing? By job, education, okay, we are calculating the mean, and then looking at only 2. Oh yeah, so if you had to work with hierarchical index, if you were to work with this index, okay, and let's say you wanted to extract one of these rows, okay, you would want to define this column and this column, because this basically becomes a composite key, okay. And if you ever dealt with a database, right, and you will know what a composite key is. It returns a data frame with a hierarchical index, a composite key in a database, okay. And you have to pass on a tuple, the entrepreneur, the job type is an entrepreneur, and education level is primary, and then you can sort of calculate the mean of age, housing, and loan, okay.